Hello, thank you Amy and everyone who makes this possible. I'm Adrian and I want to tell you something about AndroidAPS, a do-it-yourself closed-loop system popular mostly in Europe and Asia. A little bit about me. I'm a computer scientist from Germany living in Austria and currently finishing up my master thesis in pervasive computing. Pervasive computing is a special concept in software engineering where computation happens anywhere and anytime, so it focuses on things like embedded devices, sensors, machine learning. Many have heard of the Internet of Things as a catchphrase. My involvement in the We Are Not Waiting community started in spring 2014. I wanted to get better control over my blood glucose levels and went shopping for a CGM. My decision fell on a Dexcom as I liked the idea of open data, and for the G4 there was an open source driver from John Kostick already available. In summer the same year I realized this was the right decision. The alarms didn't wake me, and with the help of that driver I was able to build an intelligent alarm clock on a Raspberry Pi that even spoke back to me. In autumn the same year, I was missing statistics, so I made again use of a tool from this community, the Nightscut Chrome Uploader, and started to add statistics and reports. This was my first contribution in the sense of paying it forward. In spring 2015, I wanted a more robust and mobile system, so I became an Xtrip user and joined the development team. Xtrip is a CGM app for Android that at first only captured Dexcom G4 signals wirelessly, but now has evolved to a full CGM suite with extensive features that works with almost all sensors and transmitters on the market. Not too much later, I found myself to be one of the main contributors to Xtrip and was even preparing the release versions. Even though my focus changed towards community feature requests and bringing the app further, my personal goals still were tighter control, better monitoring, and information to enhance my traditional therapy parameters. So I added statistics, history lookups, smartwatch integration, BG read-alouds, and with all this and the intensive diabetes management it allowed, I had quite good control when looking at my numbers. Good control? Only when looking at my numbers. Quality of life suffered. I didn't hear the alarms anymore, a common phenomenon called alarm fatigue. New possibilities to manage and then micromanage my numbers meant more needed alertness, more stress. It became hard to switch off and relax. It was just too much, and I knew I needed automation. I needed a closed loop. So I was looking at the open source do-it-yourself systems available, and these three were on my shortlist. Loop, that was presented here by Nate Radcliffe last year, runs on an iPhone, with which you also do the interactions. It connects via a small hardware device called Riley Link to an unfortunately now discontinued Medtronic pump. RF0, that Dana Lewis showed you the year before, uses the same pump. The user interaction is done via the pump itself or a smartwatch, and the APS algorithms run on a small Linux microcontroller. And AndroidAPS, initiated by Miloš Kozak, that runs on Android. It works with a Dana R pump, quite an underdog still, only available in some markets in Europe and Asia. It has the advantage that we can directly control it via the Bluetooth on the phone, so no need for special hardware. RF0 and AndroidAPS both are OpenAPS implementations. In fact, AndroidAPS builds on the same core decision-making algorithm. The decision was easy for me: AndroidAPS. First of all, I like developing for Android. A new pump with 4 years of warranty and consumables paid by insurance has its merits. And most of all, I already knew Miloš, the initiator of AndroidAPS, and I get along very well with him. Here you see him with his family visiting Austria. Teaming up with Milos has been productive. We complement one another as we have slightly different points of view. He as a parent of a child that has type 1 diabetes, I as an adult user. Here you can see a common setup. A phone that runs AndroidAPS and usually also acts as CGM. A smartwatch as optional tool to more comfortably monitor and control the system. And a Dana R pump. The pump at first looks a bit unimposing. With just 71 grams, it is the smallest and most lightweight infusion set pump on the market. So easy to hide. Its strong suit is that it's fully Bluetooth controllable and you never really need to touch it during the day. I've heard there are plans to release an updated version to the US market next year. Let's have a look at the development timeline of the open source closed loop systems. 2 years ago, Dana presented the first one. Last year, Nate showed that the vision of Pete to have a more integrated system had become reality. And this is where we are this year. It feels right on track. Now, I want to give you a short overview over the app. This is the home screen, where you do almost everything from. You can monitor what the loop is doing. The upper chart shows the basal changes, glucose values and treatments. For the lower chart, you can choose to show more detailed algorithm-specific data, like insulin on board or deviations and others. In the upper left corner, you can see in what loop mode you are. Here, closed loop. You can switch to open loop or suspend the pump. In the upper right corner, you see the current target range. Directly from the home screen, you can do the most popular interactions, like temporary targets, bolus and carb entry, or use a bolus calculator. To get started, you set up your basal rate and carb factors. You can monitor the pump states, and if you want to go into detail, you can see all the internals of the algorithm. But when everything is set up and running, the home screen is mostly all you need. Let's have a look at a typical interaction like a bolus from a smartwatch. What are the traits of AndroidAPS development? As I've already pointed out, we use the algorithms from OpenAPS. But also a good way to not invent the wheel twice is to interoperate with other apps. We do so with Xtrip and Night Scout. Xtrip gives us offline CGM data, and Night Scout is used for remote monitoring and cloud backup. AndroidAPS has a modular structure, and what are the benefits? It can be configured to the needs of the user. For development, it is easy to add new components and features. And due to encapsulation, a developer can restrict his work to one component without the need to fully understand the entire system. A typical example is the integration of a new user interface, like a smartwatch or a new pump. Johannes, one of our developers, is working on and already using a plugin to control the Roche AccuCheck combo. We've already heard about internationalization today. For AndroidAPS, a ritual has emerged that a few days before a new release, a call for translations is made. It is really great to see how people really search to help with the translations. Great user involvement. The effect is now that 11 languages are available. Here we see the Bulgarian, the Korean and the Czech version. Having two perspectives on the system, as a parent of a child and as an adult user, led to different kinds of interactions. While I would want a bolus via my watch or a full bolus calculator and have all functionality offline without the need for mobile data, a parent might prefer a single programmed button as interface for a child, active only at certain times like snack or lunchtime, and do the rest via text messages. As the knowledge the user comes with can vary a lot, we guide them towards the closed loop. He has to run through certain objectives. The system only lets you pass to the next one when it notices that the user has achieved the current one. Coming to the big question, does AndroidAPS help? I'm totally convinced it does. We haven't completed any clinical studies yet. 2 are in the makings, 1 in Czech Republic and 1 in Korea. But still, I've yet to find a single user who says it does not improve at least one aspect of the diabetes management. I personally achieved my goal of stress reduction. My A1C stayed where I wanted it to be, and the amount of alarms dropped to just 1/5. This is a small case study of a young woman that donated us data from before and after starting with AndroidAPS. I don't want to go too much into detail, but you can see that during the night the 25th percentile is below 4 millimoles per liter, or 72 milligrams per deciliter, or in other words, hypoglycemia at least every 4th night, and still having high values at other nights. With AndroidAPS you can see a much narrower ribbon indicating less fluctuation. Especially during the night the low values have become far less without any more high values. Comparing the two, you see her time in range increased from 55% to 82%. And in my opinion, it's a rather narrow range from 4 to 8 millimoles per liter, or 72 to 144 milligrams per deciliters. A few numbers about AndroidAPS itself. Back when I prepared the slides, we had 250 daily active worldwide users, and it's a fast-growing community. At the moment, we already have 380, more or less. In Germany, we're around 50. Recently, a third developer has joined us. And there are many users who help with support, translations, graphics. Really everyone can help, and if it is with motivation. This is a good example for motivation. Here, we see the typical behavior of a digital native. He just discovered the feature of bolus via the watch for the first time. He didn't even have directions yet.